So the machine I've got in the bay today is a Volvo BL70. Just while we're talking about hydraulic system maintenance on mobile equipment, I just want to talk about oil and filter changes first. So I'm looking in the operator's manual for that machine. It says to change the hydraulic oil every 1,000 hours. And procedures here, and then it talks about changing the hydraulic system filter, which is a spin-on element on this Volvo BL70, and it says to change that every 500 hours. So we're going to be changing the filters more often than the hydraulic oil. Very common on mobile hydraulics to see that, and quite often this is sort of the intervals. You're going to change the hydraulic filter every 500 hours. Every second filter change, you're also going to dump the oil out of the tank. Now, how much oil is in the tank versus how much is in the machine? The hydraulic tank, there's actually a unique setup on this machine. It's got an upper and a lower tank, but in combination of those two, it only holds 41 liters of oil in the tank. So when we do that change at 1,000 hours, we're changing what's in the tank. We're not changing everything in the machine because there's probably at least another 40 liters in all the cylinders, hoses, oil cooler, the pump itself. So we're probably changing about half of the oil every 1,000 hours, and the objective there is that over the lifespan of the machine, the overall cleanliness of the hydraulic oil will be sufficient for long-lasting components. Now, if you do scheduled oil sampling, your oil sampling may indicate that you need to change that oil more frequently, or you may get into a scenario where you'd want to run the machine after an oil change for a while, then maybe change it again. Because again, we need the oil to circulate through all the circuits, get back to the tank, and then it's just by a process of random chance that a particular molecule of oil may end up going out during that change. But overall cleanliness with that maintenance schedule should be maintained. Why are we changing the oil and the filter at different intervals? Well, this machine, our BL70, has what's known as a full flow return filter behind the rear axle underneath the machine. There's a spin-on element. It's about, I'm going to guess, about a 40 micron element. It's designed to grab 40 micron and larger size particles, which are particles you can see with the naked eye. So why are we changing the oil at all? Hydraulic oil actually doesn't wear out. And often when you are changing it, it looks pretty good. It almost looks like new oil you're draining out. The reason we're changing the oil at all is so we can get the particles that are smaller than the filter will catch to get them out of the system. So particles below 10 microns in size may do some damage in the system. 20 microns for sure, 30 microns. If the filter's only grabbing 40 micron particles and larger, it's not 100% efficient, it's not grabbing them all. But we got to change the oil periodically to get rid of the smaller particles. So that's why we change the oil in a hydraulic system, is to get rid of fine contamination. So that's a good reason for doing oil sampling. I like to cut filters, use a filter cutter, and cut the old filters open, have a look in the outside of the pleats. I've got lots of filters I've cut open here. We'll look at in a second. But when we do that, we're looking in the outside of the pleats to see what's going on in the system. Is there dirt and debris in the system? Is there any shiny metal? Is there any, we can use a magnet to figure out if we got ferrous metals or aluminum. And we're going to look in the outside of the pleats and see what we see. But that's where we're looking for large chunks. If we got a full flow return filter, we're looking for particles we can see with the naked eye. Well, most oil sampling labs, when you send your sample in, the first thing they're going to do is run that through a 20 micron filter before they feed it to their machine that's going to analyze the oil. So oil sampling is looking for small particles, and that oil sample report may tell you whether or not you have to shorten up your oil change interval. Whereas looking in the filter, you're looking for large particles that oil sampling is not going to catch. So one does not replace the other. I always recommend doing filter cutting and oil sampling. So we're looking for, again, big particles in the filter. We're looking for small microscopic particles with oil sample reports. So not all filters are full flow return filters like our Volvo backhoe loader uses. This one, here's a Caterpillar filter that's called a high efficiency filter, hydraulic oil filter. That is probably a 10 micron filter if we looked up the specs on that. and it probably is not being used to filter all the oil returning to the tank like we're doing on our Volvo. Often a high efficiency or a 10 micron filter will be used in a kidney loop system on the machine, where only one circuit's returning oil will be filtered at that smaller micron size. Because if you had all of your return oil from the entire system going through a 10 micron filter, you're probably not going to make it 500 hours before you clog up that filter, and it would go on bypass. So where you see finer filters on mobile hydraulics, you tend to see those in a kidney loop application. Where you see 35, 40 micron sort of size filters, you tend to see those in a full flow return situation. Now you may also have some hydraulic filters that are just mesh screens. That may not be as obvious, that might be designed to maybe be serviced, or they may be an integral part of the machine that isn't designed to be serviced. That may just be designed to keep some debris out of specific areas of a system. So here's one that's just a wire mesh screen. I've also got a pilot system filter off a John Deere tractor loader backhoe, and it's this style of filter that uses a sort of a steel mesh inside, and you don't service it inside, you just take this apart and toss it, put a new one on. So sometimes the filters are unconventional looking, but may still have a service interval. And then another filter, of course, might be a breather. If you've got a vented tank or even a pressurized tank, there may be a breather in combination with a vacuum breaker and pressure relief, or if it's a vented tank, it may just be a breather like this, where the air coming and going as the hydraulic level changes in the tank, it has to move through this breather so we don't draw air in with incoming, dirt in with incoming air. On our BL70, instead of it being a separate breather like this, it's actually part of the cap, the fill cap on top of the hydraulic tank. But regardless, there's generally a service interval for this, whether you take it apart and change the element inside, or you toss the whole breather and change it. On the BL70, they have you replace that hydraulic tank cap. The breather's not serviceable within the cap. You just change the cap, and that's servicing your breather. I have a couple different filter cutters that we use. These more modern filters, especially these AFSI or Donaldson ones, they've got fairly substantial aluminum head on them, so you got to get down a little deeper with the cutters. So this is a Caterpillar filter cutter. This one's also a Caterpillar filter cutter, but it's just a shallower model. Both of those are available in the Caterpillar One Safe Source through their parts department. And when you cut open these cartridges, of course, some of our filters are not going to be a spin-on element. Some hydraulic systems use a cartridge that we would just install through a cover on the hydraulic tank or in a separate housing. But often there are cartridge type on more modern machines just for convenience. So I like to cut these cartridges open, or cut these replaceable filters open. Again, we'll find the cartridge inside, and we're generally looking in the outside of the pleats because the oil is going to get filtered from the outside in through a modern hydraulic filter. And we learn several things by cutting open hydraulic filters. We learn what kind of quality of filter we have. We can see how much pleat material there is, whether it's a paper or synthetic or coated paper. We can see if there's any kind of wire mesh over top or screening over top of that filter material. We can see if there's glue being used to separate the pleats, or whether there's something a little more sophisticated like this spiral fiberglass band. These two filters came out of this one says Donaldson, this one says Cat. They externally look very similar. They come out of the same filter plant, FSI plant. They're both made on the same production line, but you can see there's different levels of quality once you cut them open. So what fits may not be as good a quality of replacement. And you're really saving nothing by cheaping out on filters. If you look at the whole owning and operating cost of a machine, filters are this little sort of sliver in the pie graph. If you look at operator wages and fuel, those are generally, and then the purchase price of the machine, and you start to pare it all down, you find out that filters are this little tiny fraction of a % of the owning and operating cost of a machine. So trying to save a few dollars with an aftermarket filter rather than OEM is probably not doing you any favors. So again, we're looking in the outside of the pleats for debris. So we find out the quality by cutting the filters. We also get an idea of what's normal. If you're looking in the filters every time you're changing them, you get used to a certain level of alarm when you see the odd flake of aluminum, or maybe a little bit of brass, or a little bit of steel, or a couple flakes of paint. You'll know what's normal, and you'll know when to be worried and when to not be worried. So it's good practice to get into. You can also then recycle the good scrap value of steel, and maybe there's a filter recycling facility in your area that will pick up this part. So what I'm not finding in these filters that I might expect in other type of spin-on elements like an engine oil filter, I don't see a bypass in here. This filter is actually bonded to the filter head, and there's no bypass check valve. There's no spring loading of the element inside like you might find in an engine oil filter, and especially in an automotive application. And that's because the filter bypass, more commonly in a hydraulic system, will be in the filter base or filter head that the filter mounts to. So here's a hydraulics filter and its base, and of course oil comes in this system. Oil comes in this side, comes in here dirty, comes through this port, goes in through the pleats of the filter into the center tube where it's then clean, and then it comes this way back to the tank. So the oil's going through here, through the filter, back in through the tank, and then in here is where we've got a bypass check valve. So there's a spring-loaded disc in there, and if the restriction through the filter is too great because it's plugged with debris, or because the oil's cold on a cold winter morning, if the oil can't go through that medium, filter medium, it can push against that spring, open up this bypass check valve, which is kind of a relief valve, but it's a bypass valve, and the oil can then go through the filter head or filter mounting and uncleaned, unfiltered. Big benefit to that, rather than having a bypass down in the bottom of the filter like an engine oil filter might in an automotive application. In this style, if debris that was trapped by the filter drains down into the bottom of the canister overnight, then at startup, when the bypass opens, it's not going to blow all that debris through the system like an engine oil filter may. So a little better design to have it in the base. Some automotive engine oil filters are going to that style as well. But if you cut open an engine oil filter, you're typically going to see a bypass check valve. Again, if you're not buying the OEM filters, you might be buying a will fit that would have a bypass valve in it, which wouldn't be necessarily the best thing for your hydraulic system. So time well spent for the 2 or 3 minutes it would take to cut open a filter with a proper filter cutter and see what's going on in the system, get used to what's normal in there, and look for dirt and debris above that size particle that you can see with the naked eye. Of course, if you're just removing a cartridge type element out of the hydraulic tank or something, it's generally not too difficult to, sometimes taking a sharp utility knife, cutting out a section of filter and letting it dry will give you a better idea of what you can see in the pleats. But again, we're looking for, first thing we're going to look for in here is lots of metal or any kind of thing that looks shiny like a jewelry store. We don't want to see that. And also on the topic of quality, I've got another Donaldson filter that I opened up this week, and I was surprised to see that they hadn't, at the factory, they hadn't put the clue all the way around here. And we can see there's some pleat bunching going on here. And again, I like the better quality filters that come out of that plant that have that fiberglass band glued on. But on this one, probably only 3 or 4 pleats were doing the majority of the filtering. Around this side, that wouldn't have been the path of least resistance for the oil. So again, you get a good idea on quality control. And it looks like it must have It looks like it was glued that way. I'm not sure if this, maybe this is intentional. I can't understand how it would be. I think the machine messed up on the installation of this filter, and then it poured the glue in there and glued it, but it glued it in this position. So some quality control issue on that particular one. Assuming it's legit, and there are, I don't know if there's maybe counterfeit filters out there. And this particular Volvo backhoe loader also has a filter bypass indicator symbol on the warning panel on the dash, as well as hydraulic temperature warnings and hydraulic malfunctioning warnings, cold temperature, hot temperature, oil level. Lots of warnings on this machine pertaining to the hydraulic system. But the filter bypass, on the filter base of this machine, there is a I'm not sure if it's a mechanical switch that's tripped by the bypass valve in the filter, or if it's a pressure differential sensor measuring upstream versus downstream pressure at the filter, but it's going to tell the operator that the filter's on bypass or bypass is impending. And I'm not sure, I'd have to read a little deeper. Some manufacturers tie that warning in with a hydraulic temperature indication, and they may not give you that warning if the oil's cold, because again, sometimes we expect that filter bypass to open when the oil's cold and thick and won't fit through the medium of the filter. And to prevent a nuisance warning, sometimes they'll just put a switch in series with a temperature switch, and once the system's up to operating temperature, then if you get that bypass indication, it's an issue. But you'd have to read the operation maintenance manual for each particular machine to see if it says what to expect with that light. Some machines, the light might come on every cold morning, and it might say in the verbiage that it's not something to be concerned about if it goes off once the oil warms up. But a common complaint when a filter is bypassing is that, you know, my filter bypass indicator isn't on when the machine's cold, but once the machine warms up, then that light comes on, and that just may be the strategy of the machine. It may have been on bypass the whole time, but you may only be getting the warning once the system detects that the system's approaching operating temperature. So I'm just going to slide underneath the machine here and have a look at where the oil filter lives for the hydraulic system. A creaky creeper. So we're actually back underneath here. Here's the rear axle of the machine. There's the right rear tire, and there's our filter base. And again, I see wires going up on top. There's a Deutsch connector up there. There's some wiring to the top of that filter base for whichever type of bypass indicator there is on this filter. But like a lot of tractor loader backhoes, filter's in kind of a vulnerable spot. This one's actually a little better than some I've seen because it is above up sort of tucked in behind the axle, but it's still a vulnerable spot. If the operator gets the machine buried, they can damage this filter. One of the most common issues with these filters is improper installation. People love to over tighten these filters, which can cause the filter to leak. I've seen them tightened so much that the crimp where the filter can crimps onto the filter head it'll actually turn, because someone's over tightened it so much that the filter's actually not threading on anymore. They're actually starting to spin the outside can. So you don't want to over tighten these. Follow the instructions for installing the filter properly. Again, this machine's a little unique in that it's got two hydraulic tanks. It's got a lower tank down here that's sort of underneath the cab floor. So there's the pump. I've just moved up in front of the rear axle here. The pump is here, and there's sort of a tank down here, and there's a suction line to the pump. So this is a flooded inlet to the pump. The pump is lower than the hydraulic tank, which is a nice design for preventing cavitation. This machine's got a Rexroth axial piston pump. But then coming off of that tank, I've got another large suction line that runs up in front of the transfer case of the transmission, and that hose takes a 90-degree turn and goes up, and I'll show you where the upper tank is. So up in here behind the engine, you see where my muffler is, etc. Back behind the engine, there's the upper tank. It's got a sight glass on it. It's not the most convenient spot. You got to lift the hood here to get to that sight glass, but there is a sight glass. Probably because that isn't that convenient, they've also put a warning level switch, a level warning switch in the tank that triggers a light on the dash if the level gets low. And then up at the front of the machine here, we've got a oil cooler. This is a hydraulic oil cooler, sort of in between the engine rad and the air conditioning condenser. There's instructions for cleaning that cooler out in the operation and maintenance manual if the hydraulic system is overheating. And then here on top of the, just in front of the front windshield, behind the hood, this is where our hydraulic filter is. And this is our hydraulic tank vent that again gets changed. I think it's every 500 hours I recommend changing that cap to change the hydraulic system breather. So you're maintaining the level of the upper tank, but there is a lower reservoir as well before the pump. So that BL70 is using the more common radiator type hydraulic oil cooler, where you've just got, in that case, an aluminum rad and the airflow that's moving through the engine radiator, and the air conditioning condenser is also moving through that oil cooler to blow away the heat. But some machines, if I brought in our John Deere 310 SK tractor loader backhoe, we'd find it's got a cooler that looks more like this, where it's a heat exchanger, and we've got a bundle of copper tubes inside there, you can see. These are the oil connections on this particular one. Over here I've got the coolant connections, so engine coolant will go through the center of the tubes. Hydraulic oil will go around the copper tubes, and copper is a very good conductor of heat. So whoever's hotter between the hydraulic oil or the coolant will transfer their heat energy to the colder of the two fluids to stabilize the temperature. So this type of cooler, I believe why they're using this on the John Deere 310 SK is just because it's got a Tier 4 emissions engine. There's so much stuff packed under that hood, plus an air-to-air aftercooler core, etc., that they've just run out of room at the front of the machine for another radiator. So they're going to take, this is mounted on the frame rail underneath the machine, and they just transfer hydraulic heat energy into the engine coolant, and then force the engine radiator to deal with that heat as well as the engine heat. Big advantage to a heat exchanger type cooler, though, it can actually warm up the hydraulic oil. If I took that BL70 that we just saw, if I parked it outside in a cold morning and let it idle, the hydraulic oil is never going to warm up. It's in fact going to cool it down because I'm blowing air across the hydraulic oil cooler. Whereas this type of cooler, because the engine's thermostatically controlled, it can actually warm up, and the copper tubes can transfer some heat energy from the coolant into the hydraulic oil and start to warm up the hydraulic oil a little bit. So it's more a heat exchanger rather than just a cooler. But got to be careful with these types of coolers if they're on a hydraulic system, because they can leak. The solder joints where the bundles of tubes are soldered in, if they start to leak, we can get hydraulic oil and engine coolant mixing, which isn't going to do a lot of harm initially to the engine cooling system likely, but having antifreeze in your hydraulic system can make an issue. I've got this one just kitted up for pressure testing to see if there is if we pressurize the inside of the tubes. There's a maximum pressure rating on this one of 125 psi. So we can put shop air pressure inside the tube. So the way I've got this fitted up, I put a gauge here, I put the shop air line here. And then with this full of oil, I can watch for bubbles to let me know if I've got any leakage. But if that leakage is happening, you can contaminate your hydraulic system with coolant. And that's again where oil sampling is a good idea. If you've got potassium or sodium trending up in your oil sample, that can indicate that you've got engine coolant. Of course, you got to be careful that you don't want to blame the cooler until you do some investigation. It could have been someone using a funnel for the engine coolant and then using it for the hydraulic system, but if it's a trend that's going on and worsening, it could be an indication of an impending failure of the cooler itself. They can be rebuilt. At least this style can. Some can, some can't. So that's just some information about maintenance of hydraulic systems. Yeah, we tend to follow the operation and maintenance manual to the letter on these machines. Use OEM filters, cut the filters, do oil sampling, and if you do have dirt contamination, trending high on an oil sample or you're seeing contamination in the filter, then start to look for where that dirt might be getting into the system. Check wiper seals and look for leaks on hydraulic cylinders. That's a very common place for dirt ingression into the system. Look for proper installation of the cap on the hydraulic system. If it's a pressurized tank, make sure that pressurizing system is working properly. But as a general rule of thumb, if you got dirt coming into the system, you're going to have oil leaking out somewhere. So look for those spots where your hydraulic system might be leaking and correct those, and that usually helps with reduction of dirt getting into the system. If you do have dirt in the system, sometimes when on a machine where you've got a full flow hydraulic filter, a 40 micron or a 35 micron filter, you may be able to cross-reference that to a 10 micron filter that will fit the base. And I know Caterpillar has a reference for what they call clean-out filters, and clean-out filter document is just a reference showing you what 10 micron filters will fit where 40 micron filters were originally. And those can be put on for short durations to help clean out the system. You can run it for a shift or 2 shifts or until the bypass indicator comes on if equipped, and help to clean out a contaminated system that way. But you're probably going to be wanting to shorten up the oil change intervals as well to get fine contaminants below even what a high efficiency filter can grab.